Everyone, welcome in and thank you for joining. We'll go ahead and get started in just a minute or so. And while we wait, feel free to say hello in the chat and let us know where you're from.
They start coming in quickly, huh, Ian?
Oh yeah, once it
300.
starts, it seems to never stop.
Yes. Hello, hello, New Jersey, Tampa, Fargo, Iowa, Virginia Beach, Seattle, Pune. Wow, okay, there you go.
New chapter.
Barcelona, buen dia, Ottawa. Good day.
There we go, people from all over.
Pakistan, howdy. Morocco. We got the whole world.
Um, I'll go ahead and kick us off. So, good morning, good evening, good afternoon. Seems like we have a pretty global audience here. And welcome everyone. Thank you for joining us for today's AEE member webinar, where we will discuss innovative tools and techniques for applying fundamental M&V concepts, which is a part of our ongoing CMVP webinar series. So, I think this is part 2 at this point. My name is Ian Watsky, and I'm the Membership Engagement Specialist at AEE. And I'm joined today by a global panel of M&V experts. So to introduce everyone, I'll start off with today's moderator. Steve Cromer is an energy engineer with over 30 years of experience in the industry. Steve serves as the chair of the CMVP board and is also the author of the recently published AEE book, which is titled The Role of the Measurement and Verification Professional. Joining Steve is John Petsy, who has over 40 years of experience in the industry and is the co-founder of Sky Foundry, which is the creators of the SkySpark Analytics platform. John also has previously served in multiple roles, including as president and CEO of Tritium, the VP of product development at Andover Controls, and the executive director of Project Haystack. Our third panelist is Hassan Yunus, who is the co-CEO and founder of Griffin, which is a leading multidisciplinary design, district cooling, energy efficiency, and sustainability consultancy. Hassan has over 18 years of experience in the industry and currently serves as an AEE and ASHRAE trainer and sits on committees for both. And last but not least, Pierre Langlois has 35 plus years of experience in the industry and is the president of Eco Nolaire, which is a renowned international consulting firm in the energy field. He also acts as the president of the Sofiac, which is the largest super ESCO in Canada and France, and also serves as the co-chairman of the Global ESCO Network. So I want to give a huge thank you to everyone in our panel for joining us today. And before we do dive into the presentation, I'll quickly mention a couple of housekeeping items for the webinar. So first off, this webinar is being recorded, and I will be sending out a follow-up email tomorrow morning with a link to a recording of today's session. This webinar also offers 0.3 AE credits for live attendance, so that follow-up email that I send out tomorrow will also act as your certificate of attendance to confirm your credits so long as you did attend live. And also in that email will be a link to view and download the slide deck from as well. We should have time after our initial discussion for a Q&A. So if you do have any questions, please put them directly in the Q&A box, and we'll try to leave the chat open for a general discussion. And then if you would like to direct your question to a specific panelist, please just make a note of that in the question as well. And that is it for housekeeping. So with that, I'd like to officially welcome and turn it over to Steve Cromer.
Thank you, Ian. Thanks to AEE actually for hosting these webinars as well, bringing together this community. Thank you to my co-hosts. Of course, the junior member Hassan out there in Dubai, who runs an amazing operation across the Middle East, and appreciate your contributions. And Pierre, my longtime colleague up in Canada with that great new program, Sofiac. And we're going to hear from John, who also I've been able to work with, fortunate to work with several times in the last 2 years at AE webinars. Thanks to all of you. But mainly thanks to all of you who just joined this truly global group. You represent, the vanguard, the front line on taking energy management and turning it into, useful products, useful services for all your clients, and to help, manage energy to help save the world. And it's a changing world. The energy transition, as we know, is changing how we manage energy broadly in at least 3 ways. One is we have all these new types of supply and variations on the grid, which are making it really challenging to manage energy and understand exactly how to quantify your impacts. We see AI coming in large quickly. That has at least 2 big implications, one of which is that there's like analytics possible now that weren't possible not 2 years ago. There's also huge amounts of grid resources needed to fuel this stuff, and that's creating a whole new opportunity to do energy management to support the AI data centers that are coming on. Finally, from a perspective of M&V, we have emerging markets, so to speak, for our products in the form of carbon credits and just reducing carbon as well as energy. We have ESG, at least in the United States, with corporate entities wanting to know if they can get a scorecard for being a good corporate actor. And we have things like virtual power plants and immediate demand side stuff. So here we are with a group, an association of energy managers, all of you whose day job is to go out and help your clients save energy. And we're trying to figure out how to quantify it within all this changing transition and changing world. So it's a big ask, right? It what makes M&V fun and for the future a really important job. So we're very fortunate today, as part of this ongoing series of webinars, to have someone with a lot of history in the background and potentially, I hope, some time in the future to help us out, John. Um, and detailed history on collecting the data and doing the analysis, building tools to do that for clients for a wide range of end uses, including M&V. John and I shared panels at several AE conferences on M&V panels, and John was always like the most aggressive advocate for developing standards, interpreting the standards that are out there, and generating cooperation and agreement among the parties involved on how to quantify the impacts from all the great tools he was selling with SkySpark and SkyFoundry. So with that, John, let you talk for a while. This is hopefully informal, so bring in questions and we'll try and get around to all the questions we can, and we'll have input from Hassan and Pierre throughout. So welcome, John. Take it away.
Yeah, thanks so much, Steve. And really, really excited to be part of this panel and to be able to, share the panel's collective knowledge with a group that from around the world, because this really is a critical, important topic, right? People need to see the proof that the investments they make in ECMs are paying off, right? And it's not easy. So let's start. A quick introduction to our subject, right? Measurement and verification. What is it? Well, simply it's the process of determining both the energy and other value impacts of programs and changes we would make to better manage energy, right? And, in order to get started, we need a general assessment of the overall situation and then formulate an M&V plan that's acceptable to everybody. And that's going to be a real focus, right? Because in the end, what we need is agreement among the stakeholders about the reported results and activities, right? And there's a lot of calculation involved, but there's a lot of planning, assumptions, and assessment in order to make this successful. So we're going to have two core themes today. One's going to be purely the human factors, right? What is involved in successfully developing an M&B plan, the process, setting our goals, the assumptions, right? And this brings out really probably the core theme today. The primary role of the M&V professional is to facilitate the development of a clear plan, communicate that well. And this means that we need to know more than just engineering. We need to understand the broader financial issues, contractual issues, regulatory issues, and other concepts that are involved in these very cross-disciplinary M&V plans. And I took this statement from the recent book that was released, right? The only truth in M&V is the proper execution of an agreed upon plan, right? And then we're also going to talk technical elements, right? The different methods that can be selected, ECMs, and the role of data, the increasing role of data in accomplishing M&V. All right. When we talk about M&V, we're talking about measuring the impact of some type of energy management changes to the building, ECMs, right? Energy conservation measures is the typical abbreviation we use. And they fall into four categories that I think are worth a quick review, right? Sometimes we are upgrading equipment, replacing equipment with more efficient equipment, redesigning HVAC and other systems, upgrading lighting, etc. Then there's the behavioral changes that we can make, behavior of people, but also the building, right? So set points and schedules and controls turning lights off when they're not in use, adjusting thermostat settings, etc. There's a whole different segment of demand management, which we're going to talk about a little bit of detail later, right? Reducing energy consumption during peak periods, which might have a major financial impact. So demand response programs, maybe adjusting schedules, maybe temporarily shutting down non-essential equipment, maybe switching to different fuel, which is the last method, the common method, right? There may be opportunities to switch in real time, or there may be a project to go in and change a building from its previous fuel source to a more efficient, cost-effective, or renewable fuel source. Here's what's key. Depending on what ECMs we're working with, the M&V plan is going to be different, right? So we have to take that into account as one of our first decision points. So let's talk about some requirements at a high level, right? As we said, the M&V plan has to align with the selected ECMs that are going to be the project. But it's also going to be appropriate for what the objectives of the client are and the risk tolerance of the different parties, the risk tolerance of the owner, occupants, and the people organizations who may be funding the project. It's got to be appropriate to the value of the project. We have a specific example about this, right? What is the overall value of the project? Well, that's going to dictate a lot of the parameters of an M&V plan. It's also got to match the time frame, right? The time frame of the implementation of the ECMs and the time frame of the financial model that we're using to measure the results. And then finally, it's got to match up with the available resources. What are the resources available to do M&V, and what are the capabilities of the different people and teams, right? So the takeaway here is there is no singular correct M&V plan. It is the role of the M&V professional to develop that plan in accordance with the ECM selected and the requirements. So a little more about the guidelines or the guiding principles that we should be considering when we're developing an M&V plan. We have to focus on the accuracy, but that means we want the highest level of accuracy possible that's appropriate for those previously mentioned requirements. We clearly want to be transparent. It is essential that we be transparent and clearly document this plan and the results that are going to come from that plan. We need clear explanations, and we have to realize that not everyone involved in this is an engineer. The next thing, it's got to be consistent. We have to have a consistent plan and consistent practices throughout this project. Otherwise, we can't compare earlier results with later results. It's also got to be objective and unbiased. Oftentimes, that's why a third-party M&V provider is brought in, right? It's got to be relevant to the project, the ECMs that have been selected. And finally, it's got to be cost-effective. We have to ensure that the benefits of the energy efficiency project, the ECMs we're implementing, are not outweighed by the cost of measuring and verifying the impact, right? And this is a really key point, because as engineers, so many of us are, we're focused on precision. But let's talk about this with a specific example. All right, how do we balance accuracy, which relates to the effort and cost of M&V, to the cost effectiveness? And I think this is a good example, right? Our goal is to be as accurate as can be justified based on the project value, right? And we want to keep our M&V costs small relative to the value of the savings being evaluated. So here's an example. What do we use for our cost of energy? Energy costs can be calculated using a static dollar per kWh factor, or they can be calculated very precisely using detailed tariff charges, right? Including real-time tariff rates that may change over the course of a day, course of a week, month, or season. But here's the challenge. Collection and calculations based on tariff data can be very time-consuming and complex, and they will add cost to the project, the M&V project. So we need to consider how precise do we need to be? And that's an essential element, because we can't go for perfection most often, because the project costs just won't support that. Now, no discussion of M&V would be complete without just a quick touch on the protocols and the different types of M&V options, right? I took this information from the Energy Value Organization. AEE has materials on this. We're not going to spend a lot of time on this, but the point is there's different ways we can go at measuring the value of our ECMs. We can focus on just a key parameter, like did we reduce the kW draw for lighting? We can look at a wider set of parameters, all of the parameters that are relevant to the changes we've made. We can look at the performance of the whole facility, or sometimes we could do it with a calibrated simulation. These have been generally accepted as different options in an M&V plan. We'll leave further investigation of that for your own research or for another session. So let's talk about some guidelines, right? We want to clearly define the objectives of the M&V plan, and we need to communicate them. This means the scope of work, right? What is going to be accomplished both with the ECMs and the M&V? What type of performance metrics are we going to use? And who is responsible for the different roles in accomplishing this? We need to communicate regularly, not just drop a result at the end, right? There needs to be progress reports, and we need to remember that the language needs to be understood by everyone who's going to consume these reports. We also have to have a process to address concerns and issues raised throughout the process of M&V. Things are going to come up, right? And by timely response, we build trust and credibility and continue to maintain that alignment among all of the stakeholders so that the results are acceptable, understood, and credible to everyone. And of course, that means we need to take feedback. We might need to make changes to make sure we continue to align with the expectations of all of the stakeholders. All right, well, let's switch to some of the technology. Definitely want to speak about the role, increasing role of data and how it's affecting the M&V profession and M&V practices. I think everybody would agree. Data is fundamental to the monitoring and verification effort, as well as commissioning and energy analysis. What we're facing now is that more and more data sources are available, right? Real-time data feeds, historical data records from building automation systems, smart meters. The cost of sub-meters is dramatically reduced so that they can be applied where they were not financially viable before. Utility companies are offering APIs to get data directly from them in real time or in daily batches. Data loggers can be installed. There's access to tariff rate data through both utilities, government agencies, and increasingly a number of commercial enterprises who collect and aggregate that. There's weather data, there's greenhouse gas data, and there's more. So what does that leave us? Well, it leaves us with huge challenges because there's more data available than humans can deal with manually. We're drawing on a lot of experience of people on the panel. M&V used to be a sheet of graph paper and a pencil. That's how you did your data collection, right? Well, that'll say how old some of us are on the call here anyways. But there's more that can be dealt with. That's an absolute impossibility. And there's also challenges how we're going to access that data. Look at those data sources I've just mentioned, different protocols, different data formats, different ways of getting the data. So there's more complexity. And what that means is we need more tools. And in general, software under the term of analytics has become the tool that is used to deal with all of this data. So what we're talking about here is software can now communicate with these systems, get that data. It can normalize the different data formats and turn that raw data into a uniform data set that enables us to accomplish our next steps, right? Which is we're applying calculations or rules or algorithms or doing pattern recognition and increasingly applying AI techniques so that we can get actionable, valuable information out of all of that raw data. Some quick examples, right? Fault detection, that has a key role in M&V, because if we implement our ECMs and then the equipment stops performing as expected, well, we'll call that a fault, right? Simultaneous heating, cooling, going outside of schedules, sensors not functioning, sensors that may be essential to our M&V effort. We need to know if they stop working, right? But then there's all of the calculation of the things we used to do with a calculator, or even before that, right? We want to calculate our key performance indicators. We might be looking at conversion to greenhouse gas equivalents. We'll talk more about that in a moment. Energy costs on tariff rates. Trying to do that manually, very difficult, right? And then we want to calculate our energy use with equipment operations so we can see the patterns, which gives us insight into where we can make changes, right? So this is what we're going to do. We're going to get that data, we're going to normalize it, and then we're going to be able to use it in these different ways. So what I wanted to do in this next section is to take some of the common goals of most M&V plans and then show how software applications can directly solve those issues for us, provide those end results. So we're going to go.
Hey, John, hi, Steve here. Hey, thanks. And Ian, maybe you can jump in, and thanks for that intro. It's great. John, I'm already thinking I'm going to engage you in the helping with the M&V course a little bit. These slides are great for the intro. But I'm seeing people raising their hands for questions, and there is a question and answer box, Q&A box. So I think that's the place people can submit questions, and we'll be getting to them later, just to let people know. And Ian, correct me if that's wrong, or let people know how to do that. I see there's someone just did that. So, okay. Yeah, check the Q&A box if you have questions. We'll get around to them, and several breaks are scheduled throughout this webinar, so you'll have a chance to answer some of your questions. Sorry for the interruption,
Okay.
John. Yeah.
Yeah, no problem. I mean, we want to make this as much a conversation. I'm glad you brought that up, because sometimes people put their questions into the chat, which is not what panelists are looking to answer.
No. Yeah. Put them in the question box, please. Yes.
All right, great. Okay, so and don't hesitate. All of the panelists jump in anywhere here. So, all right, so let's look at some examples of key M&V goals and activities and how they may align with software tools that are available to us as professionals. So we're going to look at these 6, right? Baselines. Baselines are probably one of the most fundamental things in an M&V program, right? What was it doing before we made our changes? And generating the baselines and then visualizing them so that we can apply our professional knowledge to get insight, but also to do comparisons with other baselines, calculations, etc. And then there's normalization of energy data with factors that are relevant for the project. Verification of equipment and facility operating hours, right? Those behavioral things we mentioned earlier. Detecting drift over time, key element of M&V, and detecting outright faults. And then also, we're going to talk about the impact of tariff rates and GHG factors. So first topic, baselines, right? Baselines are key. We want to take our past operation, analyze it against our post-ECM results, right? And sometimes these baselines are calculated or collected based on past performance data about the building. Sometimes they're based on simulations and model-based baselines, right? Especially in new construction where you don't have historical data. And we get a quick example here of a delta baseline, really one of the first simplest steps, right? We have a baseline, and then the software applies our post-ECM data on top of it, right? So here we're comparing our peak demand against the previous year's data less 10%. The implication being our goal was to reduce our demand by 10%. And we can see from the bars where we are above or below the 0 line, where we're above or below our baseline, right? So this gives us some good insight. Hey, we're above our baseline a lot. why? What are the factors that could affect this? So that moves on to an area where we need to combine data. And when we're combining data from those different data sources, right? The energy data may be from electric meters or BAS. The weather data may be from a government feed or some other source, or it may be from a weather station we've installed. But we're combining different data sets together. And now we can see on the bottom what our KW profile looks like, our demand profile. But up above, we can see what was the weather across that period of time. We can apply our professional judgment to that, but we can also take the next step, right? And use the software tools to take us further into analysis by using a common tool regression analysis, which will help us see what is the correlation between our energy demand and temperature. And that's typically expressed as the R² value here shown at the top left. And this highlights the strength of the relationship between weather and energy use. And this is extremely important because not all facilities are highly impacted by weather, and not all ECMs are highly impacted or directly impacted by weather. So, in this way, we can see how we can compare our baseline and basically take weather out of it as a factor. All right. Well, that brings up our first example of energy normalization. In the previous example, we're normalizing based on degree days, or we can go into greater detail, degree hours, et cetera, right? But there's other things we may want to normalize for. So weather, degree days, temperatures, et cetera. But maybe we want to normalize on building size because space is being added or additional space is being occupied during our project. So the energy use goes up, but wait a minute, we added a whole nother wing to the building. And other types of production factors. Did we change the occupancy schedule? Are we measuring it directly with occupancy sensors of some type, or are we just following a schedule? How about revenue? A busy restaurant likely consumes more energy than a not busy restaurant. So can we bring in point of sale data to see the activity of the restaurant and then normalize our energy use based on that? Or other unit production like you'd see in a factory. You make more widgets today, you'll likely use more energy. Let's normalize based on that so we can take that impact out of the analysis. And then other site-specific factors. And I would say this is one of them, defining what those factors are is a key part of the M&V plan, right? We need to know what things could affect our energy use, our demand, et cetera, going forward after our ECMs. And that brings us to another example here. We want to be able to see how equipment operation is affecting our energy use, consumption, and demand. Software lets us do that, provides a nice visualization example. At the top, we see our demand profile, but directly correlated with it, we see the start and stop operation of our equipment. So we say, hey, look, we're slamming on RTU cooling stage 1 and 2 and the fan all together, hitting a demand peak. Maybe we should have some soft start strategies involved, right? So it can lead to ECMs we want to accomplish, or it can lead to analysis that shows why we're not achieving our goals. When we talk about goals, in many ways, we're talking about our key performance indicators, calculating them, presenting them, and then also tracking them, right? So software can allow us to calculate any type of key performance indicator we want, right? Whether it's our energy use or cost, or both, per square foot, per unit of production, per hour of occupancy, per revenue produced by the facility. That's a good key KPI. But then there's other things like PUE, power usage effectiveness, often used in data centers. And then there's delta KPIs, right? Compare our current value against previous values. Another key performance indicator would be the number of faults. How many events are we having where our equipment is not operating as expected? So the software can allow us to automatically calculate all of this. Again, another thing that historically would have spent a lot of pencil lead, if even possible to do. All right. But then when we have KPIs, what do we want to know? We want to know how they're trending over time. Here again, a function lots of software offers to trend those KPIs so we can see what direction they're heading in. Tracking KPIs over time is often, or I'll say virtually always, a key element of an M&V. The software tools that are available will allow us to do this basically automatically once we set up the KPIs. And the next topic is, fault detection, detecting patterns in equipment. It's detected a number of ways: pattern recognition, other AI techniques, right? The software can look for patterns and detect those patterns. And they're often patterns that would be extremely hard to find or take a lot more time to find if we're doing it just manually by human effort. One of the things I like to bring out is, we talk about pattern recognition and detecting faults in equipment. Faults can be more than an outright "it's broken" type of fault. It could be patterns that represent cost changes, efficiency changes, comfort, safety, occupancy, performance, or financial results. We can have KPIs that look at purely dollars and then have algorithms that detect important patterns when they change by a certain amount. So it's not just about finding something broken. I think that's an important point about using pattern recognition, which is typically called fault detection, right? And then software tools will allow us to visualize those patterns. When are we seeing these problems? Cooling failure, dampers not operating, temperature sensor failing, right? Simultaneous heating and cooling, short cycling. When are we seeing them? Visually seeing them so we can get right to the issue, make those corrections to support our ECMs and the successful part of the success of our M&V plan. So we touched on this, but I think this is really important to bring out again, right? We're combining data from different sources. This is, I would say, one of the new challenges of working with all this available data and using these great tools that are out there, right? If we can bring together from, data from weather feeds and utility APIs and submeters and BAS, they're all coming in different formats, and that becomes part of our challenge, right? How do we bring that together? How do we normalize all of that? The benefit is, by combining different sources of data, we can see relationships that you could never find by looking at an individual system, right? Let's look at a couple of examples beyond weather. I mentioned this early on. Tariff rates are important financially. They may be a part of the ECMs implemented, and therefore tracking them or using them is going to be a key part of the M&V plan. And I like to start with this. Could you actually end up paying more for using less energy, right? The answer to that is yes. Under certain rates, if you use less energy, you'll pay more. Could you use the same amount of energy and just pay less? Well, yes, if you're on a different rate that may be a new rate that's available or more appropriate for your facility, So electric costs for commercial facilities are typically calculated on fairly complex tariff rates, and we can utilize software tools to do what would be very hard manually, which is to turn the energy consumption and demand into dollars based on complex rates. And here's just a quick example of that, right? The lines on our charts are our consumption and demand. The bars are our cost. And I think this highlights a really interesting example right here, right? Our consumption curves, consumption and demand, aren't that much different than the day before, but our rate caused us to have much higher costs because maybe we went through a threshold, an important threshold on the rate, right? This is very important to understand what ECMs make sense and how we're performing against them. But there's one other aspect. Increasingly, projects are being implemented to reduce greenhouse gases, to improve our GHG results. That means we might not actually be saving any energy, but the ECMs are related to greenhouse gases. And so that means the M&V plan has got to be related to greenhouse gas reduction, all right? And in order to do that, quite frankly, you need software tools to do that. the software tools, many of them out there allow you to do this. They basically take your energy data and convert it to equivalent greenhouse gas data, right? There's a number of data sources available. Here are just a few of them that are available. And how you want to report that. Remember, we talked about reporting to the constituents of an M&V plan. Maybe I want to see it in equivalent passenger miles driven, equivalent gallons of gasoline or diesel, et cetera. All of these tools are available. And increasingly, as M&V professionals, you're going to be involved in tracking projects to reduce greenhouse gases. All right, well, we get another break point here. Steve, if any questions have come in, be glad to do it before I move on to kind of my last topic.
No, thanks, John. I have a couple of comments and maybe the other panelists do regarding some of the stuff you just said, but let's just encourage people, if you have questions, to use the Q&A box. So that's that. And yeah, since we're breaking, on that last slide on the greenhouse gas, and you've done a really good job of laying out the challenges of, I mean, both the benefits and the opportunities from real-time data from various sources. And I know you're going to go into more detail on that later, like how to get it done. Some people are asking about all the various software suites of tools that are available for that. And I said, your Sky Foundry, and that's pretty good. There's lots of others. Well, a full list might come later from AEE, John, if you want to contribute some of your old competitors. But what's happening on the greenhouse gas side is I think it used to be these factors that were developed and published, and now we have a lot more real-time data there too. What do you know about what's going on with that? Like being able to match up real-time locational data to carbon reductions and any developments in that area?
Yeah, so that has definitely progressed in the last 2 to 3 years, right? There's some commercial companies out there that are doing the hard work of connecting with the utilities and the operators, the grid operators, to get those data feeds out, right? I agree with you. The examples I have here are more the static greenhouse gas conversions. But you know, Steve, this brings us back to our precision question, right?
Yeah.
How precise do we need to be? What is our goal, right? Maybe the static data is perfectly acceptable for the goal of our project, but there may be another project where no, we need the real-time feed, which I believe some of the commercial operators are offering it up to every 30 minutes now, maybe even faster. So you know what fuel and what greenhouse gas output is coming from the energy you're using. But guess what? There's a cost to that. Two costs. One, you're paying that provider. You're also having to do the extra work to integrate that into your program, into whatever software you've selected. So it's there, but you've got to say, is that going to bring me enough value against the goals of my project? Again, that key point about M&V.
Right. That's all about finding all the potential value streams from your project that are available wherever you are in the world, whatever the program is. And back to the role of a professional, to keep it general, it was and great to see 543 people out there around the world. Yeah, I mean, all of you have unique challenges in terms of where you're sitting right now and getting your projects valued properly. And we get that. And yet we all share these general issues and general challenges. And we're watching this transition where the changing availability of data and the changing value streams coming from different programs like carbon reduction. I don't know what just happened in COP29 in Azerbaijan, but things like that are stuff to be aware of. So we see what value streams might be available in the near future for all of us in energy management. So anyway, I'll let you keep going unless people have other questions.
But even one quick example of the reality of that over the years, I've been involved in projects where the demand charges were higher than the consumption charges. So for a certain customer, demand was the primary thing that the ECMs needed to address. And then other areas of the country where there were no demand charges, right? And same thing with greenhouse gas. Why are you trying to reduce it? Is it for social responsibility, or are there financial incentives for you to do that, right? All right.
Well, actually, we do have a couple, just while we're looking here.
Okay.
So you mentioned a lot about collecting data on, and this is a general topic too, and I know you're well aware of it. And it's a big thing in M&V. Okay, so you can collect a lot of this data in the baseline to support the general operation of M&V, but what happens when you have COVID and the occupancy varies for reasons that might have been relevant in a baseline period, but might not be in the future? how do you deal with changing conditions? When how do you structure M&V? How do you how do you communicate with all the partners in your M&V environment when you have changes like that, or basically the non-routine adjustments?
Okay, so that's a really interesting question because I actually had some experience with an organization that dealt with that. They had started a program to start tracking and implementing some better controls across somewhere around 100 bank branches. This was actually in the Czech Republic, by the way. Okay, and then COVID hit, right? And this is a key point about what you can do with software that's out there today. They were able to, with the software, first of all, see the change and demonstrate the change to all of the stakeholders, and then make calculations based on the change that explain to people that the ECMs were still of value, right? Even in these changes that happened under COVID, right? And only with the data and the tools to do the calculations and visualizations can you bring people around a table to show that, right? And say, yeah, we need to make adjustments. These are one-time adjustments, right? You can't just say, well, I think we should, so.
Cool.
Okay, there's actually a case study out there about that that's pretty fascinating about how they did it. It was actually a government funded organization in the Czech Republic who was helping businesses with their energy consumption, and they did a really interesting case study on that. So I could follow up with that later.
Great.
All right. Well, you kind of made a good transition to all of this sounds great, but what are the challenges? What's involved? Especially around the topic of using data. We've really talked about what's involved in the professional, organizational project planning. What are the challenges around the data? Well, I'd break it down into 3 categories. There's data acquisition. What does it take to communicate with these external systems? How can we get the data? Is it going to be live? Is it going to be batch? Is it going to be meters, sensors, new devices we're going to install as part of the project, right? Then when we get all this dissimilar data, how do we normalize it or harmonize it? A number of different words have been used for that. How do we take what's known as multi-structured or not structured data and normalize it? There's 2 major projects out there. Of course, I've been involved with Project Haystack, and there's also the Brick Schema project out there. And there's DOE work being done to advance those standards. And then there's the whole idea that gets to your point, Steve. How do we modify, customize, define rules, algorithms, change KPIs, et cetera, right? We're going to need that flexibility because most likely we're going to need to make some changes. So this pictorial here kind of talks about the process, right? Step 1, connect to available data sources. That is one little picture that is a huge part of the project. How are we going to connect? What are we going to be dealing with for different protocols, different data formats, et cetera? Once we get that data, it's got to go into some repository, database, product, et cetera, and we've got to normalize it. Normalize it so that it is structured and tagged so that we can perform calculations on it, so that we know what 25.4 means. Is it a temperature? Is it a pressure? Is it a kW value? And then the next steps can happen. Calculate those KPIs, look for those anomalies, see those trend drifts over time, look for those correlations, produce our reports. All right. And when we talk about acquiring data, the protocols, we've got BACnet, we've got connecting to IT systems, SQL servers, we've got SNMP for IT systems. We've got an OPC and Modbus for meters and industrial systems. The point is you're dealing with a lot of different data protocols and formats. You've got web service feeds like we talked about from utilities or real-time tariff rates, et cetera. So that's a big part of the project now, is understanding what's involved in that. And then the effort of giving the data meaning with tagging and semantics, right? Adding tags that describe what it is. Interesting, you read about AI. One of the big unseen parts of accomplishing AI is to add metadata to the training data. right? There's people, hundreds of thousands of people around the world tagging data for those training data projects, right? And one quick example, because I'm near wrapping up here, meter data. Meter data is simple, right? No, meter data isn't. Meter data can be available in lots of different formats. This format I can actually read as a human being, right? But sometimes it comes in software formats like Zinc and Turtle, JSON, XML. So even dealing with meter data that may be, if you will, freely available from a device or a utility provider, you're going to face the challenge of different data formats. And that leads to, I think, important point about our profession is that working with data is now a core skill of the M&V professional. That doesn't mean you're going to be the software engineer. You're going to be the one mapping the data. It means you need to understand the concepts. You've got to understand these core data concepts for you to develop and manage your M&V plan. Even though other engineers, technicians, software engineers who have the skill sets will be doing it. You've got to understand all of these protocols are out there and the security barriers, if you will, that may be involved in getting that data. Oh, I know that protocol, I can get to it. Can you? Can you connect to that site? Does the security regime of the organization make it difficult or near impossible to get that data? And then, of course, we know the human factors, right? So all of these are now essential skills. And I'll close with that, right? The key points we've made today. There is no singular correct plan. It's our job as M&V professionals to develop it. Data is a fundamental part of it. And working with data is now another core skill of the M&V professional. So with that, I'm going to stop there. And Steve and the panel, and hopefully our audience with questions, we can go on from there.
Great. Thank you very much, John. That's a great overview. I actually would love to have you keep talking about some of the more detail. I know you've got so much experience, even with this Project Haystack and some of those things where, as we all know, that's where the devil in the details, that pyramid of time that's required, to get all that stuff to actually work can be voluminous. And that's one of the challenges, like you said, of a professional. How do you balance the reality of what's available versus what's possible cost effectively for your project sizes? So we have about 5 open questions we can get to, and they look pretty good. So I'm going to encourage everyone to use the Q&A box as we go through. I'm going to let my other panelists comment a little bit right now. I have some questions of my own. But why don't the other panelists come in right now, and then we'll just kind of go free form for the next 40. We have like 40 minutes left. So thanks, John.
Thanks, Steve. Thanks, Steve, and thanks, John, for the great presentation. And would like to start a discussion on the concept now that we're focusing quite a lot on climate change reductions. So energy efficiency is the best tool, but we have to extend the paybacks, right? If we just focus on the 1 or 2 year paybacks, then we'll have an issue. So if we want to have long-term energy efficiency project that will be paid back over a long time using different financial mechanism, would it be grants, would it be super ESCO type of things and all that, it means that we will have to measure and verify savings for a long, long time. And option C, as you know, as you discussed as well, is been probably the option that's been used the most, but it has its downfalls when you look at very long-term measurement verification. So what is your intake about using A and B and not only C when you have such long-term measurement verification and demonstration of savings to be done?
Yeah, that raises, I think you're raising a really, really interesting problem that we have, right? And I think one of the key changes is that at the beginning, we have to understand what is the duration that is really justified by this project, and can it be served by, options A and B, or do we really need to look at the whole facility or both, right? Maybe we focus on option B, but we're also collecting the data that would support a whole building, analysis over time. We have that data, right? So that because what happens, the building gets sold or something new comes up that there is new money available for that greenhouse gas project, right? that could happen, right? Maybe we'd been chasing that. We couldn't get it. We'll start with an energy conservation measure, and then, hey, we finally get the grant, right? All right. So I don't have a singular answer for you, but I think you raised a really interesting challenge that we're going through as we move towards tracking or projects focused on greenhouse gas reduction.
And I'll let the sand comes in because I don't want to mobilize the first questions, but just to
Yeah, and
follow up on that one.
I do too. So let Hassan come in though.
Yeah, but let me just finalize and build on that one. Is essentially that when you use option C, the precision level is obviously limited at some point because building evolves quite a lot. So it needs a lot of adjustments. And that's where cost comes in. So you talked about the relationship between cost and precision, but option C, short term is one thing, long term maybe cost, not that cost effective. But Hassan, you can build on that as well. Other questions?
Yeah, I think maybe my point would be on the costs involved. So I think, John, and thank you very much for the presentation. The issue that we typically face with clients is that they've already put some good investment on their building management system or building automation system. And then we have this new kind of, let's say, analytics above it. And they're like, wouldn't that could be done on my own system? And in some cases it could, some cases it cannot. So I think the costs involved and we need more case studies on that. Like, what are the costs involved and what could we get of those? I mean, I've seen multiple platforms. SkySpark is one of them. I've seen others as well. I'm not going to name them now. And it boils down to the quality of data and how is this being used. Like, I've seen it really useless in some buildings where no one is doing anything about it, so they get all these notifications, and then they have some. Let's say I've seen one with some savings calculations that did not make a lot of sense when looked at the details of the data, how they're doing their regression and their baseline adjustments. So I think what we need more is kind of some case studies on, like, this is an actual building, and look, you may have added or invested this much, but look at how much we were able to achieve, and not only from the energy savings, but you have some maintenance savings that could be achieved. You have some comfort issues that can be handled. I mean, these rules keep getting evolving. We keep on learning and understanding how these different systems work together. So maybe yeah, some light on like the costs involved and kind of what is the payback of such systems on our a typical, let's say, project.
Yeah, if I could just add to that, Hassan, and for John and for the whole crowd. I mean, John, you sell a software package that's got multiple value streams in its own right. So you're able to layer in M&V as a service within selling SkySpark. But how do people who don't have that already have SkySpark or have those other value streams? That's a general challenge.
Yeah, well, I think Hassan made number of good points here. Some of the automation systems have an adequate amount of these tools in them. But the problem is those are some of the most recent systems, right? So if someone's got a BAS from 5 or 8 years ago, it likely has limited tools in it, right? Because its main goal was control, sure. Right? Some of the more recent ones do. But one of the things that's helping this is a model of where the service provider is the one who has the software, right? The M&V professional, the consulting engineer, and they go in and use that tool. The owner doesn't buy the tool, they buy the project, and the engineering professionals are using that to make it more cost effective to do a project, to streamline their work, and to get their economies of scale, right? So that they can do more projects with the same team, right? So an M&V project doesn't necessarily mean the building owner has to buy and run the software, right? I think that's very important. I'd say that model is common among available from virtually all of the successful providers of what's considered analytics today, right?
True.
Because let's say it's going to be a 2-year cycle, and it's about equipment retrofit. We've got to prove that we're installing these new chillers, right? The owner may not be inclined or financially justified to buy this stuff. They buy the M&V effort.
Yeah, I agree. I mean, from my point of view, since we have a limited, let's say, as a consultant engineer, an M&V engineer would be there for 2 years, it's just a shame that this is not kept on. And what I see, the best thing you get from such algorithms and rules and such, let's say, additions to your BMS or BAS is that you get a lot of info that can help you run the building efficiently. So, okay, it's not only about how much we save the energy, but also how can we save more energy and make sure that the ECMs are actually working. So, 2 years from now, we, stop using it because we're out of the project, and then the client's back to whatever they were doing before. So I feel that has to be part of the, you know, part of the system so the client can keep on using it. And it's going to be a nice 2 years where they kind of learn and see how things are done. I think that is something that we should push for, is that making sure these analytics are there in those systems.
Yeah, I couldn't
Hey,
agree more. But of course, I have a biased position, but just a quick mention of that. You mentioned the improvement in maintenance and other things. The Department of GSA, who was the world's largest property owner, implemented a program. And when they had to report out multiple years on their results, they had their own M&V challenge. It wasn't just about energy. And over this is available public information, 50% of their savings was related to maintenance. 50%. Because they understood better what are the real problems. Then they could analyze what's the cost of fix them, what's the payback of fixing the problem, right? And so it should be continuous, but that's a challenge I think we as an industry have to overcome.
hey, I want to keep on that theme a little bit with Hassan, and just recognizing that Hassan, you run or co-founded Griffin, and Griffin brings to the table all your experience with ASHRAE and developing auditing and submitting up front the data to support what John's trying to then collect data on and verify. So I think within M&V and the professional, we still have a lot of work to do to coordinate that handoff between the CEMs out there, the CEAs, all you 500 and something people who have a wide range of jobs and roles, 533 still listening. Yeah, when you're interacting with your facilities, like how do you use your information to go present a project? Like before this even starts here, like with the the M&V part, how do you visualize or quantify or report what you think is an opportunity? So Hassan, what have you seen there in terms of getting better information up front, and how does your firm do that?
I think if we're doing an audit or managing an ESCO project, for example, and we have something like SkySpark available on site, that makes life way easier. And that's not typically the way, or what we find. So typically we might find some BMS, but and I think we have another problem in the world of BMS or BAS, that sensors are just not accurate. I think uh, the manufacturers are going as cheap as possible to be more competitive. So we find, at least from looking at maybe more than 1,000 buildings, we rarely go to a building automation system and look at and see accurate sensors for many reasons. And this is another point where the diagnostics can tell you, look, this does not make any sense. We can't have 30 ppm CO2 in a mole. It's not make any sense. So whenever we have these systems, it makes it way easier to produce any audit, because you already have the end use analysis. You have all this data that you can analyze. You put more effort into analyzing and coming up with solutions rather than trying to find out what's going on. So a huge difference we see whenever we have a fully functional BMS or a kind of supervisor, let's say, controls or advanced algorithms. So, if we don't have that, we need to go put our own equipment, do the audit, and then the main thing we tell the client to do is sub-metering is important, and we push for such, let's say, algorithms to be added. Like you need that in order to operate the building properly. Otherwise, we might help you for a couple of years, but after that, you need someone to guide you. And these algorithms, I think, and these additional tools can help clients conserve their energy.
Can I follow that up real quick on
Please,
the point of continuing right after the project?
just John, just a second, because Marco Clerks, our good friend from Honeywell, has a question specifically on this about coordinating ongoing commissioning. And how do commissioning well, closing a job, the opportunity for better coordination between commissioning agents and M&V. So this whole idea about the role of a professional, also recognizing there's other players in the market. So whether it's the BMS sales guy or the commissioning agent, and how do we do that up front and throughout the project for M&V purposes?
I can respond to that, actually. What we've seen, it's successful, it's only beginning to be adopted, is that the commissioning team and the M&V team are selected at the beginning of the project to build a building. And they know I'm going to be installing the HVAC and the controls, and this is the guy, Steve, right there. You're going to be ensuring that I do that right. And we know that from the beginning, and it changes kind of the flavor of the interaction. We're all here to serve the owner on this project. I believe that this should be the standard approach. We're seeing it very successful, right? Where M&V professional identifies potential problems in an HVAC design before the trucks have rolled and installed the stuff, right? You want that, okay? That's what needs to happen, but that requires change in the, if you will, I guess, the construction process.
And I think the M&V in new construction is kind of non-existent in a lot of ways. So if you look at LEED, for example, they removed that credit. So we used to have a credit for M&V plan, but then they found that it's not really being used and they removed it. And I think we have to bring it back one way or another because commissioning and M&V can help each other. So we are promising clients that we're going to put these sufficient chitters, put the sufficient envelope, whatever we're putting in, and we're promising them an energy model, and we're showing them some results. In a lot of cases, our energy model results are very different than what the actual consumption is. So I think we need to bring in M&V to the new construction that will help the commissioning as well. So there has to be some connection there. It could be the same team with an additional M&V analyst within the team to study, like, we are pushing the client to pay this amount of money. Is it really achieving what's why is it not happening on new construction? Why only on retrofit projects?
I'll go ahead, Pierre.
Okay, just adding to this, and I'll tweak it just another way. Probably everybody that is listening and participating to this webinar are probably at some level, some kind of specialist. So we all are either engineers, or we have experience in M&V or energy and all that. Our clients are not. So when we talk about measurement and verification, and John said it very well, and Steve in his book mentioned it, it has to be a pre-agreement, but we're still relying on data and the way we use this data that for us makes sense, but for them, it's very, very, very complicated. And you try to, at the end of the day, if you're an ESCO, if you're a promoter, if you're a consultant, you try to demonstrate savings because there's a goal. Like, the client wants to either pay you out of the savings, or have a guarantee out of the savings, or want to have a grant out of the savings, or whatever they use it for. But we're kind of speaking within, there's a gap. There's definitely two worlds. There's the world of the experts that we are, and there's the world of the beneficiary, which often, not all the time, but often, are not that knowledgeable. So we'd like to go back to you and John, and probably the audience, about how to deal with that. We are sophisticated, but our clients are not that well educated about all that. How to bring that gap at a reasonable cost at some point.
That's one of the challenges, John, I want from your 40 years of dealing with clients. What have you learned that you can help our people? Like, how far back do you have to go? How do you couch the whole question of quantifying the ineffable nature of nothingness, right? We're quantifying, it's energy management is the creation of nothingness. How do you get that across to people?
Yeah, what do they say? You can't prove a non-truth or whatever. You can't,
Yeah.
right?
Right. Well, it's a counterfactual. Yeah. So how do you have what experience do you have? How can you tell us about your experience? All these great software tools, which you've had so much, a career in building, company and getting this stuff going. But how do you deal with people?
One of the these are painfully learned lessons too, by the way, Steve, as you know, right? You start by asking questions and understanding who are those stakeholders and what is their background. I can remember when I was a little younger, charging into a presentation, and all these wonderful things we can do for you. And the guy stopped me. He goes, I got to tell you, I don't understand anything you just said in the last 2 minutes. Okay. I'm a lawyer and was promoted to this position responsible for our facilities. What's a chiller? Okay. And that was painful, but highly educational.
Yeah.
So you got to start there. It's human factors, right? And very little to do with engineering.
So communication and asking questions, and really don't make assumptions that people understand what you're talking about in a lot of cases from a lot of different backgrounds. That goes to Pierre's point too. And Pierre, you have the question between ESCOs, between your ESCO and your super ESCO and other ESCOs. They don't communicate with all the same words and concepts. So it's just back to emphasizing that whole nature of being a professional, the role of communication. Don't take things for granted with language. Over communicate to avoid disputes, right? That's the problem. I mean, the whole goal here typically for all of you is to get your job done, get paid, get the good work done, get on to the next job, and not have an argument or dispute. Prove that it worked, but avoid any money going to the lawyer side, right? We always say that. Yeah. We got a bunch of questions lined up. So, I'll just go back to a little more detail. Just go to this one. How can you share details of any experiments you might have related to baseline calculations for demand response programs? John, do you have, whether it's, I guess, wholesale or utility program, demand response, more short-term data? How does that work?
I'm sorry, who are you directing that at?
I guess to you, have you had the opportunity to apply SkySpark to those types of programs, or have clients asked you for that? Because it is, again, as you mentioned earlier, a growing thing within rate structures that there's real-time pricing, in fact, even negative pricing in the middle of the day. So how do you use your tools for demand response programs?
So I'd say absolutely. And where I've seen it done is a number of partners that we work with have people on board who specialize in understanding rates, right? And can just from raw some historical KW and KWH data, a year's worth of data from the utility, 15-minute interval data, right? Just basic data, can quickly assess this curve, especially when you put it in the software and you see the charts, can quickly assess you're on the wrong rate, Steve. Right? Let's start there before we start implementing all kinds of changes to equipment that'll cost a lot more, right? And that first step, again, the software tools that are out there make that so much easier to do than it was in the past. Typically, you're going to get that basic meter data in a useful format, CSV. You can have it in a chart and a graph, and then using their experience, they first compare it, against their knowledge of rates. And then, as I showed, you can actually load the rate definitions in and get actual detailed information showing what those costs are. That example I showed was actually that, applying rates to basic KW data.
Okay. Anything else from the panel for now, or else I can keep going through the questions? Let's just ask this one. So Ayad Khalid from the Iraq chapter, welcome. My question: if we have 3 supplies of energy, gas, grid electricity, and solar, how can the software you have calculate the optimum model for less cost and less emissions? So integrating multiple fuel types, can your tool do that, or how do people address that? And that's a growing thing. Again, whether it's optimizing integration of renewables as part of the energy transition, or doing the energy transition away from natural gas, at least in the US, where we're electrifying. So how do you deal with how does your software deal with optimizing supplies of energy?
Yeah, the area of actually making control changes, if you will, making decision changes as opposed to identifying issues, that's a growing area right there. I don't have a specific example of that. That's typically falls into the category of simulation, right? We're going to simulate based on the information we have on those. Making control decisions based on detected data and problems, that's definitely happening, right? Modifying schedules and set points and stuff like that. But that example to me falls in the area of simulation.
Well, that's a good one too, because that's another question then we have about simulations. When you're asking, can you provide examples of common software used in simulation under quote unquote option D? Now, I want to just again broaden. I know your broad experience, your main experience, John, has been, as you mentioned, taking the situation of the various data sources that are out there and sensors, bringing them together into a software platform to use to generate analytics. But what we have facing us now, another thing with AI, is the potentially opportunity to in real time calibrate energy models. So anything you can say about energy modeling and I think the really close, how close we are to taking all the data you've been collecting and integrating it into like real time energy models, not just regression models?
The data definitely can, and as I said with my example, the hidden magic of AI is that the data that goes into the training sets has to be tagged with metadata, right?
Yeah.
That's the invisible part. And this is one of the most important things of the last, 14 years, the effort that numerous people in industry have been making around these two major initiatives, Haystack, Brick Schema, to come up with a standard way so that as we progress, data gets tagged so it can be fed into these models. The other thing that I know people are working on is automatically generating the control sequences if you have a clearly defined model of the equipment systems, right? Automatically generating that. Department of Energy is doing work on, and with ASHRAE, I believe, on standardizing control sequences, right? And now great, we've got them, but is it going to take a human being to go manually program them? Or are we going to be able to apply it to tag data and automatically select the appropriate control sequence for the equipment? Because we've got two standards, we need to bridge them. All right. And so this is definitely, I would say, on the forefront of things I think we'll all see in the next 3 years.
Yeah,
I,
it's
I
going to be
think
really exciting. Go
I
ahead.
think Steve, I'm not sure if the question is about option D, so maybe energy modeling software like IES, Design Builder, HAP, and other software that could be used. But I think what is now happening is trying to push digital twins, and that's not happening only on buildings. Could be happening on industries. We've done one for a district cooling network. So basically modeling the piping and the pumps with live data, and then simulating and saying what is the minimum pressure or the minimum VFD speed that you could run your pumps and still be satisfying all the different ETSs, energy transfer stations. So that's happening on buildings. I see a lot also happening there, but it's a little bit more complicated, especially that you need to have all the sensors calibrated. So you need to have a really well working building automation system with all functioning sensors in order to have a productive digital twin.
Right. So that's a threshold of what's existing there already, and if you have that data, how do you pump it, tag it properly, and get AI to put it into a model? And that's coming. And I think we'll be having a seminar on that probably in 2 years where it's done. Right. It's working really well in some circumstances. We do have questions though about how do you deal with situations where there isn't, okay, from your experience for old building and plants where the automation to get data is too costly. What are the minimum automation tools which you can actually try and get? How do you kind of cobble something together? Or what would you recommend for, the beginner, so to speak, or the minimum data set? What types of things would you go for?
You got to get meter data, right? And typically sub-meter data. Without providing a comprehensive answer, I got a really interesting anecdote, right? Met with one of our customers and said, hey, John, I want to make some suggestions on making your screen easier to work with because I have 450 sub-meters. And I was like, wow, you installed, and this is years ago, they weren't cheap. He goes, no, I didn't install any meters. I have VAV boxes that have temperature and airflow. And I set up a calculation and it tells me the energy flow through every one of those VAV boxes. I have 450 meters. I thought that was just brilliant way to look at the problem, right? So you got to think about, right, what data do you have, right? And how could it be used, right? Same thing you can do if you have flows and temperatures out of a chiller plant. You've got a whole way of looking at your energy, right? There, so. that often aren't done with the core BAS, but the data is available from the BAS, especially if it's an older system, you know, might not be available.
Sure. I mean, I think the answer there is, again, pitching back to what I believe is one of the greatest benefits of AEE, is that some hundred of you that are still out there, let's just see participants for fun, can share these experiences, right? This is a place where you can go, whether it's the conferences or the various other things, because there's so much nuance and so many specific issues within all of our various facilities around the world. And then to bring that forward and cobble solutions together that work within the very simple set of tools for M&V, really, conceptually, right? Including what we talked about earlier with the option terminology. I think some of you know I'm not a big fan of that terminology anymore, but whole facility analysis, the two aspects, one being regression, so just using the data to say things about physical systems versus total physical models, and that big distinction about energy models, or as Hassan said, for district cooling, any kind of simulation model. Those are like the end game, which we're not going to, can you please give me more details and examples about option D and how calibration can be made? Well, not really. That's going to be a whole separate thing. Although again, AI has got, and I probably get a paper every day now from academia in my email box about people using different techniques to calibrate energy models more effectively. So it's an ongoing research thing across the world for people to get that down. So come back for another seminar on that one later. So I'm going to go to our friend Dennis Van Ness, South Africa. Hi, Dennis. Given a large industrial site, let's just take another example with several different types of energy and different significant energy uses. Would the panel like to comment on the value of trying to model an entire facility like that with one equation compared to separate models for each separate entity within that large entity? So what do you think about trying to even model large facilities with one equation?
Steve, I can jump in on that. You mentioned that, we have an initiative, a Super ESCO initiative in Canada, which is taking long-term agreements, 15 years. And a lot of what we do is big industrial facilities. We use option A and option B exactly for the reason that is mentioned by Dennis, is that modeling a huge facility which is changing all the time with so many parameters becomes impossible. So we use option A and option B, even though we do almost deep retrofit on all the facility, but we will have 10, 15 M&V plans, one per measure, one for each system. We actually try to use A to limit that modeling as much as possible when things are obvious, like lighting. We try to use option B where the equipment are varying in their functions. We use normalized savings, obviously, because the changes cannot be on the side of the ESCO and Super ESCOs taking the risk. And we use a little bit, I know that's not in the IPMVP, but a little bit of prescribed savings in the cases where the cost is too high and the benefits are too low to justify 15 years of measurement and verification, as we're paid by the savings that are demonstrated. So to my experience, trying to model huge facilities that are constantly moving, constantly changing, constantly reinventing themselves, and try to demonstrate savings starts to be quite an argument. So when you simplify it by looking at individual systems, you're looking at normalized savings, and you try to eliminate what is not cost efficient to measure and verify, seems to be for us the solution.
Hassan, anything you can add to that in terms of when it might seem
Yeah, I think getting closer to the problem is always better. So looking at one equation for very large industrial facility might not be that great, depending again on the amount of savings. So if you have not much of savings, and then you have one equation to cover a whole facility with large amounts of energy, then it's better to go into individual systems. If you have that data available, then it becomes easier. I think what people, if they don't have that kind of data available, they see, well, I have only boilers, it's feeding 15 different processes, and I'll just try to do one equation for the boilers. And yeah, so if there's not much data available, can try that, but I think it's always better to dissect it.
Okay, I think the question, the larger answer there, or the more general answer is, as John started his whole presentation, and as we write in the book and elsewhere, the right M&V is that which all the parties involved can agree to, and keeping the cost to a minimum to see that the benefits of the energy management work you're doing are visible to the degree everyone wants to. And so that's the big challenge, is to always get everyone to communicate with a clear understanding of what's possible. And it's not possible cost effectively to get all the data we want. There are sometimes, and John's made a career out of putting equipment in the field that collects a ton of data that can solve a lot of these problems, but not all of them. And you still have to work with individuals and lawyers and accountants. And we all have to face the fact that the energy transition is coming at us really fast. And we have things like negative pricing in the middle of the day in California, right? Where you're saving energy as an energy manager. It's not doing the grid any good at that point. And so who cares? That's been my mantra for my last couple of classes. Who cares? Like,
Mhm.
and I don't mean like, negatively, like who cares? I mean, like who's watching and cares what the results are and how are you going to make the calculation? Because that's all that matters. Get that job done, get the good energy management agreed upon, and move on to the next one and keep doing more energy management. Don't worry too much about getting the answer perfect. Okay, so I have a couple like very technical questions. Just I'll get back to Faith because they asked it earlier. How do you incorporate changes in regression models if you have something like an OR type? The only variable used was production. This is for a diamond production plant where efficiency is measured using kilowatt hours per ton, but there's an OR type change. Any thoughts on something as general as that? And I know it's not specifically something SkySpark would handle, but I
You're
want to
producing
address.
diamond. Do you care about energy?
There you go. That's a good answer. All right. All right. I'll leave that one for the diamond experts later. Thanks for that joke. That's good. Hey, okay. How about, can this tool account for human error? And I know that's a general thing, but how do you do fault detection when it's maybe an analytical fault detection? Or what have you learned, John, about maintaining quality control, I guess, throughout the entire process? Hassan mentioned that a little bit where there's sensor error, but how do you do quality control
Yeah.
on here?
Yeah, okay. So fault detection has a key role here. I'll answer that with an example that I thought was very fascinating, right? A situation happened in a building during a very cold climate, and the night crew was there. And in order to solve the problem, they used a 2x4 to force dampers that weren't working properly closed so the coils wouldn't freeze. And then they went home. Okay. The analytics wasn't able to tell you 2x4 inserted into damper. However, it was able to identify the damper's no longer working. That means we're not going to have economizer, right? That's human error or human factors, right? Because those guys were saving the coils on an unusually cold night. They did what they thought they should do. They were the night crew. Nobody talked to them. Everybody forgot to do it. So, fault detection can identify issues that you may determine were related to human error. Somebody screwed up the schedules because they hit the wrong button on the screen because they weren't familiar with the software, and all the schedules are 24 hours a day. Fault detection will pick that up. So that is, an example.
I think that's a good example of having, we didn't talk about this a lot, but back to Hassan's whole thing with auditing and having a goal in mind. So it's a target and being off the target, but it's assessing that target, setting up that target and trusting that target and adjusting it occasionally as things change. But it's a whole side of M&V that we don't get to talk a lot about. We're running out of time for questions. I'm just thrilled that we had so many people here today, and I'm going to leave a few of them open. I apologize, but I want to cover two. One is from Lebanon because our Hassan is from Lebanon, and it's the reality that there's things like force majeure. How do we? So NGOs usually have a clear understanding, acceptable timetable change when it comes to setting up systems, but clients don't agree that the original M&V is allowed to recalculate depending on the current changes, just like the extreme changes due to COVID. Can these softwares include that more specifically? So force majeure, in this case, war, but what happens when there's large changes to the structure of the operation? And how can we get everyone, I guess the main point is how do we get everyone involved to agree to the impacts and the risks and responsibilities of those types of changes? And I guess it's for anybody, but John, do you have like, yeah, when there's large
On the
changes?
technical side, you can introduce new factors at a point in time and you're recording when they were inserted. So you know. So for this period of time, we use these factors, assumptions, and for this period of time. And you know what? If we decide we don't want to use those factors, we can go and change them just for that period of time. Now, how you come together to decide what those changes should be, that's not a technical question.
That's the professional M&V question. Okay.
Yeah. Mm-hmm.
Great. Well, I want to get at least one more in. How do we make M&V activity more friendly to the regular facility operation? And I think that's one, John, you can take on. By the way, thank you for this great presentation, but how do you communicate with the people maybe in the field, on the ground, and help them use this data better, so it creates more advantageous environment across the board?
Yeah, to get the buy-in, I think you need to make things simple. And again, I'll relate an anecdote, maybe instead of a comprehensive answer, right? You talk to a customer, and what are the main things we want, or part of the M&V plan? What are the main things we want to identify, right? And have a session, go up on the whiteboard, everybody write the 10 top things they care about, right? Okay. And then I'm going to walk up to that whiteboard and I'm going to erase the bottom 5. And people are going to say, hey, wait a minute, John, I hadn't finished taking notes. I wanted to get those. I said, it doesn't matter. What you're going to discover once you have data and use tools will completely change your view on these things. Yeah. And the point here is if somebody sees results that are relevant to their major concerns, they get buy-in and interest and energy and enthusiasm to stay with the effort. I think that's the key thing, right? You gotta make sure that there's some interesting things that are relevant. The central plant operator, make sure there's results for him, and including the CFO who's worried about the money, right?
It's critically important to communicate with everyone, and you don't want anyone working against you out there thinking that the data is harming them. So, hey, we got to cut this off on time. I promised that again we'd have 5 minutes at the end. Fantastic discussion. Questions unanswered. I apologize for that. AEE, maybe we can find a way to answer those offline and send them out to folks. But appreciate all of your contributions today, and thank you very much. Come back, see us in 2025. We'll be doing more of these webinars. Suggest topics you want us to go into more detail on, or less things you want to change. But yeah, I really appreciate everyone. Happy holidays around the world. So thank you, everybody.
Yep.
Ian, it's all yours. Yeah.
I'll take it away here. I'll wrap us up. And I'll start by saying a huge thank you, echoing kind of what Steve said, to Steve, yourself, Hassan, Pierre, and John for joining us as kind of a special guest for this one. The discussion was great. The presentation was great. The chat is flooding with thank yous right now, so it's being echoed by everyone too. So to wrap us up with a couple of reminders for everyone, I will be sending out a follow-up email with the link to a recording of today's webinar, as well as confirmation for your AEE credits. And it'll also include a link to view and download the slide deck from as well. Just staying on the topic of M&V, specifically the CMVP, for those in the US, the next CMVP virtual course is on February 24th to 26th. And I will drop a link in the chat now. There's going to be a few links I drop in the chat right now. So there's the US virtual course. And then if you'd like to see a full course schedule for anyone else, maybe you're not in the US, I'll drop a link for that as well. And I'll include these in the follow-up email I send too. And then I wouldn't be complete if I did not plug Steve's book as well. So here's a link to Steve's book as well. Totally recommend it. Great resource, very relevant if you were interested in this conversation. It's been a full year of webinars. We're coming to a close. We have one more webinar on December 19th that will discuss the future of nuclear energy in America. So you can find more information and register for that webinar on the AEE website. If you're looking to get some credits right before the year wraps up, that will be your very last chance to do so. And then lastly, I just want to thank everyone again for attending today's webinar. Thank you again to the panel. We can go ahead and conclude the session. Stay tuned for another variation of this webinar in this series in 2025. And I hope you all have a great rest of your week. Thank you all.
Thank
Bye,
you.
everybody.
Bye-bye.
Yeah, great.
Happy holidays.
Yeah.
Happy holidays.